In Linux, a device that is a cold plug device is one that cannot be added or removed from the computer until you power the computer completely down. So these are things like CPU, memory, storage devices that are inside of your computer case, expansion adapters, and those types of things. And that makes sense because those devices cannot be installed or removed from your computer unless you've completely turned off your computer. It's powered down. There's no power going to it whatsoever. In fact, removing some of those devices while the computer is turned on can potentially damage that hardware. So if there's no power and the computer is effectively cold, we can consider those cold plug devices. If you wanted to see what your computer found when it booted up, to see all of the devices, you would look in the /dev directory. These are effectively the hardware devices that have been found by your computer, and they are now in that directory so that your system can now talk to those through the /dev directory. The important thing to remember here is that only processes that are in the kernel space can talk directly to hardware. You, as a user process, can't communicate directly to the hardware. You must go through this device configuration in the /dev directory to be able to do that. That separates you from the hardware itself because you might tell the hardware to do something that is completely incorrect and that will cause the entire system to fail. So to prevent that, there is this extra step. You must first talk to /dev, and then /dev can talk down to the hardware itself. That extra step ensures that there's not an application that might be developed incorrectly that could cause your entire system to fail. In a Linux terminal, if you were to list out everything that's in that /dev directory, you'd see these device files. These special device files really represent the hardware that's in our computer right now. There's a lot of different types in here, but you can see things like CPU, you can see DVD. Here's some important ones. SDA is my hard drive A. SDB is a flash drive I happen to have in this system. So it's very easy to pick out the hardware itself and the partitions that might already be configured for that hardware. Of course, on our computers, we have devices that we plug into the computer and we unplug from the computer while the system is running. And in Linux, we call those hot plug devices. These hot plug devices are things like USB drives, FireWire drives, or anything that can be connected and disconnected from the computer without causing any problems to the device itself. If you think about that /dev directory, it would be difficult to have device files already included in /dev for every possible device that you could ever plug or unplug from your computer. It simply doesn't scale very well. So in that particular case, we don't handle hot plug devices in the same way that we handle cold plug devices. Instead, those dev files are created dynamically. If you plug in a USB drive, we're going to create that entry in /dev in real time. And as soon as we unplug that device, it disappears from /dev. It makes it a lot easier to manage the installation and the removal of those hot plug devices. There's a number of different processes and daemons we have to think about when using these pieces of hardware. One is the sysfs. This is a virtual file system called /sys that is on your Linux system, and it is one that is designed to take your hardware and export that hardware out to your system. There's also something called a hardware abstraction layer, HAL or HAL. This is very common in many operating systems, and Linux included, and there's a daemon called the hardware abstraction layer daemon, or HALD, that runs when your system starts up, that tells now all of your applications about the hardware that's configured on your computer. When we connect a hot plug device, we need another process that's going to tell the operating system that a new piece of hardware has arrived, and that is the desktop bus, or dbus. Dbus does a number of other things, but for the purposes of our hot plug devices, it's the one that's going to notify every other part of the operating system that this new device has been inserted. And lastly, we have the udev daemon, that is the udevd. That is what's creating that /dev entry for us. It is one that is listening for the U events from the kernel and then building out for us that dev entry so that we can then use that hardware. When you connect a hot plug device to your Linux system, or you remove the hot plug device from your system, the kernel is going to send a U event message that is going to be picked up by your udev daemon. And when it sees that message, it goes through a list of rules that it has to determine what does it do with this type of hardware. For example, if we were to plug in a hot plug device, first the device is initialized, then the file is created in /dev. At that point, we go through the list of those rules to determine what happens. For instance, if it's a network device, then perhaps that network device is automatically initialized and put into an up condition. Maybe if it's a storage device, it's mounted automatically, and we would check etc tab for that. And at that point, the operating system is told that a new device is ready, and if anybody would like to take advantage of that new piece of hardware, it can now use that for whatever purposes it needs. This process happens very quickly, and for the user, all we're going to see are some new entries in our /dev. If you recall earlier, we were looking at /dev and we had an SDA and an SDB. Now I have a drive here I'm simply going to plug into this Linux system, and when I plug it in, it's going to go through the process of identifying the new piece of hardware, and then it will be available in /dev. On my desktop, I might get notifications that a new piece of hardware has been installed. It depends on the processes that occur when a hot plug device is added. Now that I've added that into the system, let's perform another ls of this directory. And you see now, not only do I have an SDA and an SDB, but now my new drive is identified as SDC. And that's simply because I plugged in the hot plug device, and all of those daemons and processes took advantage of that and now have made that hardware available to me.